Hey everyone, so in today's video, we're going to be covering how to solve 3x3 systems or 3 variable systems for the Algebra 2 Regents exam or just in general. So I will show you how to do it using the elimination method. You can also use your calculator to solve it, but if they ever ask you to solve it algebraically, then you're going to have to show your work as I am going to do right now. So the first thing you're going to want to do, so you call this like step one, is to just pick two of the equations, right? It really doesn't matter. Some equations, some pairings will make it easier, but eventually you'll get the same answer. So for our purposes, let's just use the top two equations, right? So this one and this one, we'll just bring them over, and I'm going to rewrite them. 2x plus 4y minus 3z equals 12. 3x minus 2y plus 2z equals negative 9. So let's zoom in on this, and here's the thing. We want to eliminate one of these variables. So I'm going to pick the variable z to eliminate, but right now I can't eliminate it using the elimination method. I need to scale them up. So how do I do that? Well, we have to find the common factor between 3 and 2, and that's going to be 6. So how can I get each of these terms to 6? So for this top term, I can just raise the entire thing on the top by 2, right? Because 2 times 3 is 6. For this bottom part, I can just raise the entire thing by 3, because 3 times 2 is 6. So now you just have to expand this out, and I'll do this first one. So 2 times 2x is just 4x. 2 times 4y is just positive 8y. And then 2 times negative 3z is negative 6z. And then 2 times 12 is just 24. And now we want to do the same thing for the bottom. Let me change colors. Let's use this color. All right, so same thing here. 3 times 3x, 9x. 3 times negative 2y, negative 6y. 3 times 2z, is positive 6z. And then 3 times negative 9 is just negative 27. All right, now we can use the elimination method. So how do I cancel out the z's? Well, I would need to just add, because if I add 6z to negative 6z, that is equivalent to 0. And I'll switch colors here just to make it easier to read. So this becomes 0 plus, so 4x plus 9x is just 13x. And then positive 8y plus negative 6y is just 8y minus 6y. So that is just positive 2y. And then 24 plus negative 27 is the same thing as 24 minus 27, and that is negative 3. So that is equivalent to negative 3. So yeah, it is definitely a lengthy process there. But the second step now is to use the final equation that you haven't used. So for our cases, it is this equation. And now you can have you have some choice. You can either use this one or this one. For this particular one, I'll just use the top one. So you're doing the same thing, except now you're including the third equation. So we have negative x plus y minus 3z equals 0. And then this top one is just 2x plus 4y minus 3z. And you want to eliminate the same variable that you did in the first pair. So this is our second pair of variables. And we're going to just write second pair. You'll find something interesting. The reason I picked that first equation to use with this one is because the z's are already lined up, right? I don't have to scale and do more math than I need to. So how do I cancel out the z's here? Well, if I were to put a addition sign, negative 3 plus negative 3 is negative 6. So I would have to have a subtraction sign, because if you subtract a negative number, that's the same thing as adding. So negative 3 plus 3 is 0. So this goes away. And now I have negative x minus 2x, that's negative 3x, y minus 4y, that is negative 3y, plus 0. And then 0 minus 12 is just negative 12. Alrighty, so now through your two pairs of elimination, you get these two equations. This one right here and this one right here. And now you're going to be doing the same thing, all right? So you just put these two on top of each other. 13x plus 2y, we don't have to write the plus 0, equals -3. And then -3x minus 3y equals -12. So see how the terms line up. And now what you're going to do is use the elimination methods. Do I want to eliminate the x or the y value? So for this one, I'll eliminate the y value. And we can see here that we will have to scale it up in order to do so. So 2 and 3, common factor of 6. So I can scale the top by 3, scale the bottom by 2. And that gets us 3 times 13x is 39x. And then 3 times 2y is 6y. And then -3 times 3 is just -9. All right, now we're going to do 2 times -3x, -6x, 2 times -3y, -6y, and then 2 times -12 is just -24. So now we can cancel out the y's. So we have 6y on the top and then -6y on the bottom. So in order to eliminate that, we will just have to add. So we just add this entire thing. So this cancels out like we said before. So just 0 equals, so 39x plus -6x is just 33x. And -9 plus -24 is 33. And that is -33. So now we can just solve for x and we can find that x is equivalent to 1. And woohoo, we just found one of the 3 terms that we need to find. So it's a very long process. Trust me, you probably won't need to do this more than one time on the Regents. But yeah, now that you know this, we want to go back and now you can choose number the 2 pairs of equations we had. So this was pair 2 and this was pair 1. Pick any of those, right? I'll just use this one right here because it's closer. All right, so now we can just write this out. -3x minus 3y equals -12. And since we know the x value, we can just plug it in and solve for y. So -3 times -1 minus 3y equals -12. -3 times -1 is +3 minus 3y equals -12. Subtract 3 on both sides, and we get -15 is set equal to -3y. So y is just -5. And there we have found our second term. And now watch this, it works like magic. So we know 2 of our 3 terms. We know x, we know y. So now what we're going to do is return back to the top. Pick any one of these 3 equations. I'm just going to use the bottom one because that just seems like the most simple. So I want to change colors for this. Because right now there's a whole bunch of text going on. So I'll use blue. And so let's write this out down here. So -x plus y minus 3z equals 0. And like we said before, we found our x and y values. So x was -1. So -x, so -1 plus y we knew was 5 because we solved for it. -3z equals 0. So now we just have to solve for z. So let's simplify this out. This is just +1 plus 5 minus 3z equals 0. So we get 6 minus 3z equals 0. Plus 3z plus 3z. We get 6 equals 3z. And so, can you guess what z is? That's right, z is 2. So now just to make it easy to read everything, I'll just write all of our terms. So x was equal to -1. Z was equal to 2. Z looks the same thing as my z looks the same thing as the 2. Z is 2. Zoom in. And y was 5. And yeah, that does it for the 3 variable system. Hopefully you guys learned something. It's a very long process, so if you can, especially if it's multiple choice, avoid doing these steps by simply just using your calculator. You can use LinSolve and solve this. So yeah, thank you guys for watching, and